Cross multiply 12 times 12. X times 18 plus x, or x times x plus 18. X. Now you have to kind of like, hopefully you've learned something. How do you solve that?
Minus 144.
Set it equal to 0. Now you have to factor it. Okay, now you have to factor it. So two numbers that make negative 144 and could possibly add up to positive 16. Positive 24 and negative 6. These two numbers multiply to make negative 144. These two numbers add together to make 18. Those are factors. They are not answers. You have to set each of them equal to 0. So subtract 24 from both sides. Add 6 to both sides. And then you have to volunteer one of these as tribute. Which one dies? The negative 24 dies because I cannot have a negative 24 triangle side there. Boom, goes away. So the only answer you get is 6. Alright? That was off the homework yesterday, and you guys are going to see how dirty it gets, and it gets even dirtier today. I'm excited. I'm super excited. So the first thing we're going to talk about, do you remember how to find a geometric mean?
Yes.
But can you follow the instructions today? Because on your test, if it's not in simplest radical form, it's not wrong, but I'm going to take 1 point off. That makes sense? Okay. So a geometric mean is the square root of the product. So we need to find the geometric mean of 9 times 4. 9 times 4 is 36. And the square root of 36 is 6. Not bad. Whole number. You're welcome. But what about the geometric mean of 14 and 6? So 14 times 6, 84. Now what do I have to do with that? Because there are no decimals allowed today. Has anybody, hold on, sorry, I get a little ahead of myself. Has anybody been taught how to do this? Has anybody never been taught how to do this? Okay, so there are so many different avenues to do this that there's so many different ways to teach it. So I was trying to kind of hit every part of it. So whichever part makes this most sense to you, we can kind of work it that way. So for the people that know it, how were you taught?
Find all the factors.
Not all the factors, but just a factor. So we're going to find two numbers that multiply to make 84. 2 and 42 would work, or 14 and 6 would work, right?
Yeah.
But I'll go with 2 and 42. So 2 times 42. Now, did that necessarily finish the problem? Can I take the square root of 2?
No.
Square root is 42? No, they're not perfect squares. So I have to keep factoring down. 42 can split into
21 and 2.
21 and 2. Now, this is the part where I don't know how you were taught. Go ahead. What did you know?
Can take a pair of
Perfect.
twos and then move them to
So
the
like
next
I
one.
call this club radical. We're in the club, and we got a pair of 2s that are going to match up. They can leave the club together as one pair of 2s. So these 2s will exit the club together as one pair of 2s. So now I get 2 square roots of 21, and I have to figure out, can I simplify that any farther? 3 and 7, but can you square root 3 or square root 7? No. So that's your final answer. I'm gonna move this over a little bit. So at that point, when you know you have two factors, you could have split these up. And then you kind of would have immediately gotten to almost the last step. I personally prefer this method. You know the perfect square technique. So that is finding the largest perfect square that will go in there. So in this instance, it's not a pair of twos leave the club together. It is what is the square root of 4? 2. And 21 stays in there by itself. Right? Everyone learns it different. The biggest one that I'm going to get to that one in a second. This guy is really kind of like a separator for like where you guys are at, because there's a lot of different ways to do that. So if you were going to break that down, what would you do?
42.
4 and 20?
Oh, yes.
Yeah?
Yes.
I know it's not what you said, but that's what I wanted you to say.
Sorry.
So at this point, people are like, well, the square root of 4 is 2. And they're like, yay me, I did it. But you didn't do it because you can still, what?
You can simplify 10.
5 and 4.
Even more.
Not so. And then when you get to that point, Sean, if you did 2 and 10, because why not 4 and 5?
Because 4 and 5 can't.
4 is a perfect square.
Oh.
See it?
Yeah.
So it just saves a little bit of work. You can do 2 and 10, but you have to bring this 2 down. Then you have to do 2 again. 2 times 2 times 5. A pair of 2s exit the club together. 2 times 2 is 4. Alright? I'm over here doing this, twiddling my thumbs. Because what's the square root of 16? 4. Bye, Felicia. And here you go. It's one step. It's just on how rapid you can see the perfect square terms. So like there's different strokes for different folks, right? You either good at multiplying or you have to use the calculator. It doesn't matter. You'll see me sitting there kind of like, and if I don't know it, I'll just start going by 2, by 2, by 2, by 2, by 2. This is a fun one just to show. Don't be smart. Don't be smart. No, don't be smart.
Don't
2.
be smart.
2, right?
2.
2 and 2 and
72.
77.
72. There you go. Look at that. That's great.
look at all those numbers. So a pair of 3s come out of the club. A pair of 2s come out of the club. And a pair of 2s come out of the club. 3 times 2 times 2 is 12. Oh, I'm an idiot.
That's crazy.
Wow.
It always works.
Always.
You either get to a simple answer or you don't. Alright. Are we smart? What is the geometric mean of 9 times 30?
Well, look, I can't correct.
I hope you're joking.
270. Wait, well, that's.
Okay, 270. Now I'm going to ask you, what are 2 numbers that multiply and make 270? Okay, 9 and 30. Alright, so why do we even do that?
Pull the 3 out of the 9.
The square root of 9 is?
3.
15 and 2. 3 and 10. 15 and 2. No. So your final answer is? Because 3 and 10 doesn't work. 3, 2, and 5 doesn't work. None of that works. If you split this down,
5 and 6.
same thing. 5, 3, and 2. Right, so this will be part of the layered conversation today. Finally, here we go. I'm going to reteach you what we did yesterday. But I'm not going to draw any triangles today. Here's where I need honest feedback. Okay? Like, I've been doing this for a while. This is secondhand nature to me. I can see it. I can type. I can send a text from under my desk. Some of you guys, this is the first time you've ever touched this phone. You don't know where all the buttons are. So if I'm saying it in a bad way, be like, Baker, I still don't get it. Show me something different. Okay? So in this scenario, we have two theorems. Two things I'm asking you guys to memorize. Right? The easy one solves for the altitude right here. And in this instance, it's y. So the theorem is, it's a visual puzzle. The theorem goes a over y is equal to y over b. It will always work. A over y is equal to y over b. You can see how we have the matching terms there. Did that hit for anybody? No? So, I see it like this. A over y equals y over b. That's how I see it. And then it's just, you don't have to separate or redraw anything. It will just always work. Okay, some people like to see it like this. A over y will equal y over b. Give me some feedback here.
Could we do an
I see it
example?
like as
We will.
I see it kind of like as a triangle.
Okay, so the important part of this is A goes from here to here, and B goes from here to here. So it's segments of the hypotenuse. It goes this piece over the altitude equals the altitude over this piece. It's segmented parts of the hypotenuse.
So it's just the hypotenuse. It's the segments of the hypotenuse and the altitude.
Yeah, that's why it's called the altituded segment theorem. Would that have helped anybody?
No.
Yeah, that's what I thought. So A over y equals y over b. That's how you will always solve for y. That is only for the altitude inside the triangle. It goes outside over inside, inside over outside. Okay. The other one, this is generally the one that people give a lot of pushback for. This one's not as pretty. Okay. If I want to solve for x, I use this piece of the hypotenuse over this piece of the triangle, that's A over x. Then repeat x over the whole thing.
Oh, because of the big.
It's the whole hypotenuse. So when you solve for a piece on the outside, it's small piece over x equals x over the whole thing. The reason people don't like this is I could say A over x equals x over A plus b.
No.
I know you don't like it, but it will happen.
Could you then just change it to C?
It happened on our homework. It happened on our homework. X over 12 equals 12 over x plus 18 because they did not give me the whole length of the hypotenuse. That's what I did is I set it up for you guys. So, how do you feel about that one? Not as good, right? There's really like no great way to quantify that one. The book says it's easier to say short leg over hypotenuse equals short leg over hypotenuse.
What does that help you find?
Right?
What does that help you find?
X.
The short.
The short,
It helps you find x.
like the short leg or the hypotenuse?
Well, it comes the hypotenuse of the small triangle or the short leg of the big triangle. It's short leg over hypotenuse equals short leg over hypotenuse. It's a valid proportion. I know it's weird, right? I'm just talking about things. So if I want to solve for z, it's the same thing on the other half of the triangle. It's b over z. Always start out here first. B over z equals z over c.
thought it had to be short.
That one is long leg over hypotenuse equals long leg over hypotenuse. It's the same type of theorem. It's solving for two different sides. These theorems only work for this piece, or this piece. Those will always be your geometric means. So the geometric mean is A over X equals X over C. X is match. A over Y equals Y over B. And B over Z equals Z over C. That's how you get your geometric means. Makes little to no sense with no numbers there, does it? So I'm going to pick one off your paper. We're going to do it together, the first one. The application is just a little bit more complicated because you have to pick the correct theorem. So, do we see anything on the altitude inside the right triangle? So we can't do that 1 over blank equals blank over 9. We have to use X and Y. Does anybody feel like they might have it? Yes or no? Okay.
X over 1 over X over 1, 10 over X.
X is what we're solving for. That should be our geometric mean. So watch. We go this piece over this piece is equal to X over the whole thing.
Wow.
Did that hit for anybody? Okay, so while we're kind of in the brain train, let's do the Y proportion. Always start on the hypotenuse. 9 over Y is equal to, repeat, Y over. Look how fast that is. It's super fast. Can you still redraw your triangles?
For sure.
For sure. Not going to stop you. This is just faster. So now we're at the point where we have to solve for X and Y. So X times X, 1 times 10. How do you get X by itself? Can that be simplified? No, so that's our answer. Bless you. Okay, on the Y side, Y times Y, 9 times 10. Well, can the square root of 90 be simplified?
4 and 45.
Huh?
I would say
4 and
no.
45 is 2 and 45 would work.
7 and
9 and 10. 9 and 10. 9 and 10. Does that make any sense to anybody?
Yeah.
So instead of actually multiplying them out, y times y is y squared. 9 times 10 is 9 times 10. See what I'm doing there? You take the square root of both sides. Can I simplify anything in that square root?
3 times square root.
The square root of 9 is,
3 times the square root.
can you take the square root of 10?
Yes.
You can't.
That's my fault.
Easy.
Do you see how sometimes not doing math is easier than doing math if you know the end game?
Couldn't you simplify the 10 well? It would be like 5 and 2 and then 2 and 3.
But then once you do that, it would be 5
That
times 2.
was more simplified. Yeah, and then 2 and 3 for 5.
No, that's 2 plus 3 is 5. 2 times 3 is 6. These are great conversations because a lot of people make those mistakes. So you'll start to realize like that number is unsimplifiable. It's just 10. All right, there's a couple of numbers that should start popping up. All right, let's try another one. Ooh. Is anything?
Okay, 4 over 10, right?
I'll draw it for you. 4 over 10.
Yes. And then
Receive
10 over x.
Perfect.
So the 10's match up.
4 over 10 is equal to 10 over x. We still have a geometric mean right here. The 10s match up. I think that's the easy one to see. Okay, so you have one of them. And you'll use it every time. Outside over inside equals inside over outside. But don't say x plus 4. It's not the whole hypotenuse. It's just piece over piece. All right, so complicated math here. 10 times 10. 4 times x. No factoring, no square roots. That's going to happen a few times today for you. Nice little easy layups for you guys. All right, you ready? Gloves off. Go to the back. This is like your test. I'm going to give you 2 numbers, and you got to solve for everything else.
Okay, what's the
Because this is pre-AP, you signed up for it.
what's the formula again?
Okay, well, we're going to talk about it right now. So, I have the pleasure of having that triangle that I can reuse multiple times. You guys only have one of them. I recommend redrawing that triangle so you can math around it. So right now it tells us that A is 6 and H2 is 9. I have to solve for the other 4 missing pieces. I'm going to put variables there so we can see what we're solving for. I'm going to call this X. I'm going to call this Y. I'm going to call this one Z. So there's 2 ways to approach this. Set up all your proportions and see what you can solve, or set up the proportion you can solve. But you see it.
Is it 6 over 9 is x over 6?
No, it's
Yes.
H1 over 6.
So did you see it? Does that make it clearer?
Yeah.
So when I don't put a proportion there, I can do outside over inside, x over 6 equals 6 over 9. That's the solving for the altitude part. So 6 times 6,
Oh.
9 times x.
9x. 5 by 9. 4.
Yay. So go back and put that number in there.
And x is just H4.
So this is 4. And how big is h?
13.
13. Because you can just add those 2 together.
You have to use that like hot
So now you want to solve for L1 or L2?
L1.
So
You do the y over, no, 4 over y.
always go hypotenuse out.
Okay, so 4 over y equals y over 13.
4 over y equals y over 13. Cross multiply y times y.
Y squared.
4 times 13. What?
52.
What?
52.
What?
4 times 13.
4 times 13. And you'll see why here in a second. If I take the square root of both sides, and you take the square root of 4.
Yes, 2.
Can you take the square root of 13?
No.
So if you had done 52, you would have broken it down to 4 times 13. Sometimes not doing math is better than doing math. So we get 2 square roots of 13 over here. So in the event that you're on your test and you're doing that, and you put the square root of 52 as 7.21, you would get 3 points, but not 4. That makes sense? So 7.21 tells me you know how to do the math, but 2 square roots of 13 says you know all of the math I'm asking you to do. All right, so now we got to solve for L2. I'm going to call that something else. Let's go with a W. I don't like Z because it looks like 2s.
Oh, yeah.
Who's got it? Who can like regurgitate math right now?
I'm too tired.
Other way.
9 over W.
9 over W. W over 13.
Wait. Over 13?
You always use the whole hypotenuse. Okay, W times W.
Wait, hold on. Why do we use the whole hypotenuse if you're only using the little triangle?
So, when you solve for the altitude, ready for this? I need to see your eyeballs. When you solve for the altitude, you do piece over piece equals piece over piece. That's when you only use the segments part. When you have a letter out here, you have to do this piece over this piece equals this piece over the whole thing. That's the one part that people generally miss. That is long leg over hypotenuse equals long leg over hypotenuse, the whole hypotenuse.
Okay.
It's just like you can use the theorem and cheat, or you can redraw your triangles and be confident in it. Okay? 9 times 13. Perfect. Take the square root of both sides. The square root of 9 is 3. And you get 13. So you could check your math, and a squared plus b squared should equal c squared. 2 square roots of 13 squared plus 3 square roots of 13 squared should equal 13. Cool. All right, one more. Last one. So I recommend redrawing a triangle here. Anybody must make any groaning noises on this one?
I can.
Huh?
I can.
Why?
No, never.
So I'll label what you got. You have an L1. 6 square roots of 3. You have an H2, which is 3. So I'm going to step back a little bit and see if anybody has the wherewithal to kind of figure out the first proportion. It's the second theorem. So where do you have to put the variable?
The variable is H1.
This is the variable right here.
Yeah.
So by adding that variable there, you can use it, and what's your geometric mean going to be?
6
Square roots of
3 over x and then x over.
Okay, so the proportion looks like this. X over 6 square roots of 3 equals 6 square roots of 3 over the whole hypotenuse. If you put h there, then you have two variables and you can't solve for it. Like it's that easy. You just cross multiply.
Yeah.
Pretty simple stuff. What do you get?
How do you do that?
Well, that's a
How do you do this?
Let's do the one you know first. X times x.
X squared plus like this.
Okay, so then here's where we get to this part. This is like segregated math. Everybody on the outside only talks to anybody on the outside. Anybody on the inside only talks to anybody on the inside. So it is straight up multiplication. 6 times 6. 3 times 3.
so that could be something.
That can be simplified.
So 39.
The square root of 9 is,
3.
then you have to keep multiplying. 36 times 3. Look at all these layers.
Minus 180.
Minus 108 from both sides.
And then you factor.
Then I get to say the F word. Fun. Factoring.
I said the upward
X plus 12
Plus 12 and minus 8.
minus 9.
Plus 12
Minus 9.
minus 9. Because positive 12 times negative 9 is negative 108. And 12 minus 9 is 3. Those are factors. They are not answers.
So then you do x plus 12 equals 0, x minus 9 is 0, and then minus 12 both sides, x equals negative 12, x equals 9.
You have to volunteer one of those as tribute because they both won't work. Negative 12 goes to die. Because I can't have a negative 12 linked right here. Positive 9 lives. So now x becomes the number 9. A nice, pretty number there.
H becomes
Which
12.
one becomes a number 9?
This h1 becomes 9.
H becomes
And
12.
h, the whole thing, becomes 12.
And then
And then
you do the
I get
angle.
to solve for the other two.
So then you do 9 over a.
Hold on. Molly.
I really was confused on what we just saw.
We solved for this piece right here.
So H1.
H1. That was x, and I replaced the x with a 9 because I'm about to use that number to drive the rest of the problem. If I do 9 over
A
a over 3.
that uses the. And then you cross multiply.
Cross multiply.
3 squared equals 27. 3 times 9. And then you get 3 square root is a. Then
So a is 3 squared root of 3.
and then you do.
Look how fast that one was.
That's
Right.
the fun.
Pretty easy numbers there. We don't have any nasty radicals, no nasty factoring.
Then you do.
I gotta solve for L2. I'm gonna call that y.
You do
Y.
3 over
3
y.
over y equals
Y over
3 over y equals y over 12. Cross multiply.
12. Y equals 6. Square root of. You get y equals 6. L2 is 6.
That's it. This little triangle over here is so special. We get to spend 2 days in geometry talking about that one triangle. So, the first part of your test is 12 open response questions. And this is one of those 12 questions. The back part's 12 multiple choice questions.
And we're doing that
Tuesday.
Is this harder than the trigonometry?
This is light work. I hope it finally like slapped you in the face. Look, the main part of this is, can you identify a hypotenuse? If you can identify a hypotenuse, trig should be okay. Trust me, I'm really good at this. Now, this is a graded assignment. I want 26 through 31 down the front. So that's what?
6 questions.
That's 4 of them. Because I've already done 2 of those for you.
Oh yeah, sorry.
Then on the back, I want 32 and 35 done. So that is 6 questions for homework. You're welcome.
Reasonable. Thank you.
Very reasonable. Now I'll be very clear about this last part.